At risk of putting some people off because it's not got Python in the title, this video is called Learning About Bitcoin. Learning about Bitcoin involves studying how it works, looking at the GitHub code, reading an O'Reilly book called Programming Bitcoin, Learn How to Program Bitcoin from Scratch, which is not something I have skills to do, time, or the facilities to do, but I'll get to this in a minute because there's a lot of Python examples in here which teach you things that you wouldn't otherwise come across potentially. And yeah, coming back to the Bitcoin GitHub page, I nearly called it the RGGH page. For me, it's always that because that's my GitHub. So as you can see, C++, cryptography, Bitcoin, P2P, peer-to-peer, cryptocurrency. I think cryptos is it's almost derogatory when you're talking about Bitcoin because Bitcoin is digital property. All of the other cryptos are securities, so Bitcoin stands on its own in that way, really. And Bitcoin is not owned by a company. All of the other cryptos have a company behind them. Without going into all of the ideology behind all the differences in ideology between Bitcoin and the others, just understand that Bitcoin is the only fully decentralized cryptocurrency. Although it's not, is it even a currency? If it's a digital property, you could argue it's not really its main use or its main strength is as a digital store of value. In these days of rampant inflation, that counts for everything. So anyway, as you're probably looking, if you, I'll just scroll up here, and yeah, just above my head is yeah, C++, 60 to 2/3 of it is written in C++. There's some C, shell, other, makefile, M4. Don't actually know what M4 is. That's a bit ignorant of me, but Python, let's just click on Python out of curiosity. So SegWit, coin stats index, test framework, wallet, miner, import pruned funds, create wallet, RPC blockchain. Some of these words look familiar, but I wouldn't know where to begin, to be honest. That's why I wouldn't say resorting to a book. That's a bit disparaging towards books. That's why I'm diversifying into using a book. Yeah, so as you can see, lots of Python code. So this is the official blockchain repo. Blockchain Bitcoin, sorry. 223,000 issues. Wow. Do not count wallet UTF unconfirmed transaction outputs as external. When is that dated? That's 6 hours ago. Okay. Build fails on Ubuntu 22.04 with GCC. So some of these are quite very fine details. So with that being said, let's just move that out of the way. And I just want to show you this. So programming Bitcoin, it's not something which, as again, this is not going to be a video series on programming Bitcoin because as you probably guessed, I'm not clever enough to be able to do something like that. Nor is one person anyway. The whole point is let's get to it and let's look at chapter 1. And the first chapter, even the first chapter surprised me because it dived straight into yeah, finite sets. So again, because of copyright and also just in fairness to the author, I'm not going to show all of the book here. I just want to, hopefully it's encouraging you to buy it. Learning about new mathematical structures can be a bit intimidating. In this chapter, I hope to dispel the myth that high-level math is difficult. Finite fields, in particular, don't require all that much in terms of prior mathematical knowledge than, say, algebra. There's some definitions here, but they're very... to me, that just it doesn't mean anything. There's nothing to... Obviously, you show you definitions. So what is a finite field? A finite field, well, let's... finite field is defined as a finite set of numbers and two operations, plus, addition, and using dot there, multiplication that satisfy the following. So we've got a finite field, which is a finite set of numbers plus two operations. So already I'd probably get mixed up and at some point get confused between a finite field and a finite set. So a field contains the set. The set lives in the field. A bit like a cow. Right, so there's a lot of theory here. The first thing I want to get to is defining finite sets. I'm not sure if it says on this page, but ultimately we become interested only in sets of prime numbers. So a finite field of order 11 looks like this. So you use a capital F and then the little number down here, and that tells you what you're going up to. And then we've got a set over here. So the set we'll get to in a second, because this is where Python comes in handy, as you can see down here. Constructing a finite field in Python. So I must admit, when I started to read this, I didn't expect it to jump straight into Python, and knowing a little bit about Bitcoin, I thought there would be lots of history, lots of be straight into hashing, and yeah, we're not going to get there for a chapter or two. So we'll name the class field element. So the class represents, so we're creating a Python class that represents an element in a field f prime. Bare bones of the class look like this. So we pass a prime number into this class, which is called field element. We pass a prime number, and the num. So num is the number that comes after that f, the little number down by the f. So what we're creating is a field element we want to represent each finite field element. So in Python, we'll be creating a class that represents a single finite field element. Class represents an element in a field. Okay, so this is effectively an element in the set. Is that right? Notice the order of the field is always one more than the largest element. That's because you start at 0. You might have noticed that the field has a prime order every time. Yeah, that's the other word to learn, order. So in Python, we might say the size of the length of the list, whereas in mathematics, the size is what mathematicians call order. The numbers between the curly braces represent what elements are in the field. we name the elements 0, 1, 2 because these names are convenient for our purposes. Okay. For a variety of reasons that will become clear later, it turns out that fields must have an order that is a power of a prime. And the finite fields whose order is a prime are the ones we're interested in. So yeah, without really spending hours going into this, just to kind of, what's it called? Well, just to skim over. I know this is going to turn into, in a previous video I showed a clip of a video called Every Programming Tutorial. And it basically was 29 seconds long and it just said, do this, run this, and then it just showed a load of code on the screen. Again, in fairness to the author, I'm not going to expose everything in this chapter or in this book, but what I wanted to concentrate on today really was modular arithmetic. So we're going to be looking a lot at prime numbers and the modulus operator. Now, if you did this at school, you long division, so 7. How many 3's go into 7? 2. And the remainder is 1. We probably all know that. How many 7's go into 27? So that's 21. 3 7's is 21, but you can't get 4 7's, so it's 3. And then 6 left over, so 3R6. And there's another one here that you'd probably need to use a calculator for. And then, this is interesting. See this diagram here? It's basically saying, what will be the time? That's amazing. I'm 1 minute out. That's, it says it's currently 3:10. And probably when I started talking, it actually was. How about that for timing? The answer is, so it's currently 3 o'clock. What hour will it be 47 hours from now? So the way you can work that out is you do 3 plus 47, so that gives you 50. And then you can do 50 mod 12, which gives you 2. I know this particular example you could have worked out in your head because you just do, well, 48 is 2 days' time, and then it's just 1 hour less than that, so it's 2 o'clock. If it had been more, say it said, what hour will it be 21 hours from now? Then you'd have to think about it, wouldn't you? A bit more. You'd do 21 hours? Yeah, so then you would do 3 plus 21, which gives you 24. 24 mod 12 is 0, so it'd actually be 0 o'clock. 21 hours from now would actually be tomorrow midday. Just loads more examples here, and then the bit that I want to finish off with here, I nearly showed you the answer, but I didn't know this, and that's shame on me, probably because I haven't done a computer science degree, which probably would have covered it, but let's just, I just want to show you a question, and then we'll just wrap it up here for today, and in the next video we'll go into a bit more detail, but hopefully this is just whetting your appetite for what we will go into in more detail. So what I'll be doing is learning from this book and then making little videos on the bits that I've learned, and hopefully that'll be of interest to you. Don't for 1 minute think you're going to, just because the word Bitcoin's been mentioned, don't think you're going to suddenly earn Bitcoins. And I don't even know if Bitcoins is a word. I think it's what normies say, isn't it? You have 1 Bitcoin or you have 1,000 Bitcoin. The plural would, you could have sats, which are satoshis, which are, I think each Bitcoin is divided into, is it 100,000 satoshis? I can't remember. It doesn't matter. So let's. This is the first example, which again, I'm just doing the modulo in Python, so nothing interesting or nothing scary here. what was the other one? We did 20, was it 27 mod 3? So that should give us, was it mod 3? Yeah, I think it was. Yeah, that should give us 6, shouldn't it? Sorry, no. It was 26 mod 3. I can't remember what the example was. It doesn't matter too much. Was it? It was something mod 6, was it? I can't remember. Anyway, let's get to this example. So I need to work this one out before I run it as well. So what do you think the answer to this would be? Minus 27 mod 6. So if it was a positive number, actually I'm just going to make that, let's make that 7. Oh, you'll see why in a second. So if that was a positive number, you would say 7 goes into 21, that's 3 times, and you've got 6 left over. So if it was positive, well, as you see, the let's just run the positive example then, right? So that gives you 6. So 27 mod 7 gives you 6. If you run minus 27 mod 7, that should, I'm gonna stick my neck out here, I think that's gonna give us 1. Yeah. How many of you got that? I wouldn't have done. I don't even remember covering that at school, but so I think just have a think about that. Let me just set you one more. 66 mod 9. Minus 66 mod 9. Any clues? So 9 9s are 81. 9 8s 72. So what's the difference between 66 and 72? 6. Yeah. So if that was a positive number, you would say 9, you would do 9 7s. 9 what would you end up with? 63, yeah. 63, and then 3 left over. 63 divided by 9 is 7. And then you have your 3 left over. If you did minus 63 over 9, still minus 7. But it's just when you do modulo, you have to keep going back the other way. So what you're in fact doing is going up to the next, well, you're effectively digging the hole deeper, aren't you? So you're going even more into minus. So yeah, there you go. That's I don't know, a little bit of a brain teaser. Hopefully that's been interesting. If not, if you'd rather just see some, I'm not going to say web scraping. If you want to see some API stuff or some Word or eBay, then let me know. But I think this has got a lot of potential. There's so much to learn here. We can cover security with hashing algorithms. We can have, let's just have a look. Chapter 2, elliptic curves, cryptography. There's lots of kind of different defining the curve for Bitcoin. There's quadratic equations, all sorts of goodies in here. Validating transactions. Yeah, checksums, hashing, miracle trees, if you don't know what they are. It's where you like make you hash stuff at low level, and then you add all those hashes together, and then you hash you make one hash out of those hashes, so that if any of the lower level hashes change, it completely alters the higher hash that hashes. It's like parent and child hashing. More than 65,000 nodes are running on the network as of writing. I think this was written in 2019. So there we go. That's just kind of again, even on page 178, we're still testing and hashing stuff with Python. So until the next video, I hope this has given you some kind of inspiration. And even if you've just learned a bit more about modulus, so you're going to go away and test modulus. It's such a useful thing. Modulus and prime numbers are just kind of a whole field of study by themselves, really. So I'm no expert, but I just wanted to make you aware of them. And if you're interested in them and you found some inspiration in this video, then this has been worthwhile. So yeah, see you in the next one.